One of the things we love about working for the UC system is that there's a real long-term mindset and a focus on kind of quality of building, resilience, and serviceability over a long time. So there's really a long-term perspective, which leads in our work to a focus and real care about seismic behavior and seismic performance. This building had been recently donated to the university. It had undergone a complete interior renovation with a lot of new finishes and new residential units put into the building. To do the seismic retrofit, we were really looking for solutions that would not have to rip out work that had just been installed and that was meeting the use of the building. The columns of this building needed to be strengthened so that they wouldn't fail in shear. Typically, that's done by wrapping the columns with carbon fiber on all four sides. In this case, part of the issue was multiple columns in the building were located adjacent to existing finishes that we really didn't want to rip out. So we were looking at a way to do the column strengthening without access to all four sides of the column. During the bidding process, Simpson Strong-Tie provided a compelling bid, made an offer to do a full-scale replica testing of the exact situation that we were designing. In my experience, I hadn't seen a bid come in with someone offering to do testing immediately to qualify their product. So the offer to do an exact replica test was surprising. I had a little bit of skepticism that it could move that fast. Not being aware of Simpson Strong-Tie's testing capabilities, it got down to action very quickly. And that's where everyone just got to work, and it became clear that there was a path to move forward with Simpson Strong-Tie's testing lab and capability. The design process to create this test was a collaboration. Getting down to work meant sitting down with the lab manager, the technical product rep, and the project design team and review team to come up with a test that would meet the project specifications.
The collaboration with engineers is always amazing because from an engineer's perspective, they are not used to seeing such full-scale testing, and the fact that they're actually getting a tested assembly on their project, they love it. Also to test something that's buildable, right? You don't want to test something that is going to be very challenging to build on the job site.
The design of the test involved multiple specimens so that we could ensure that we would have a design that would ultimately meet the project specifications with adequate controls so that we could feel confident in the results. It was clear when we sat down to work with the Simpson team that they had real good technical knowledge and awareness of how to design a test that would give us the results that we need. The machinery was able to do the full-scale testing that we needed to mimic the actual building. So the amount of force and scale really met the requirements of a building test of this nature.
With respect to the strengthening mechanism, it used glass fabric with carbon fiber anchors. Glass inherently is also ductile, right? So when this column started shaking, the glass was able to elongate and the anchors were also able to elongate. So it helped the concrete core. That restricted its failure mechanism from a shear failure mechanism. The concrete was able to do a lot more. It went to about 12-inch drift on the columns, which is typically much higher than what you would get in a seismic application.
Project timeline was really tight to get the testing designed, completed, executed, processed, and finalized. And I was really surprised that Simpson was able to do that, but very impressed with their ability to execute.
Simpson CSS products, which basically includes FRP and FRCM, for the past 20 years, these products have been getting used more in structural applications. What we are able to do in the past few years is we are able to build full-scale real-life specimens and put our products on those and actually test it. So some of those tests have never been done before. And now the specifying engineers are actually able to see the behavior of these materials on real-life structures.
What I appreciated a lot about the team at Simpson Strong-Tie was going from the design of the test and the execution of the test to the help in processing all the results, summarizing and documenting everything that was needed to finalize the approval of the product before we went into construction.
Once we looked at the test, we all had a sigh of relief. I think that was probably because we tested 6 columns by then. We all knew it was a success.
This experience working with Simpson Strong-Tie definitely opened my eyes to the possibilities of what we might do on future projects when we're encountered with a situation that is unique or hasn't been tested before and where we need some further engineering justification for a design. I definitely felt a lot of trust in the partnership. People that I worked with at Simpson Strong-Tie were proactive collaborators. They were very responsive. They definitely delivered what they said they were going to. The capability of the local lab that we tested in was really eye-opening for me to know that it's not just in a concrete repair project, but if there's really any application that we are interested in testing, that I know who to call to talk about whether it's something that we might be able to do.